Chapter 11. Light. Introduction. Light is a form of energy that enables us to view various things in our surroundings. Thus, it sensitizes the sense of vision in human and other living creatures. We learned earlier about luminous objects, which produce light of their own, and non-luminous objects, which reflect the light falling on them from a luminous object. What is reflection of light? In this chapter we will learn more about reflection and also about the behavior of light as it hits different types of surfaces. Properties of light. Let us learn some interesting properties of light. Light is energy. Light is a form of energy. When an object absorbs light, its energy increases. For us, the sun is the ultimate source of all energy including light. Light travels as waves. Have you seen ripples in a pond when someone throws a stone in it? Light also moves like these waves. Light does not need any medium to travel. It travels through vacuum at a speed of 3 multiply 1 10 raised to the power 8 meter per second. Light travels in straight line. Light always travels in a straight line. Have you ever observed a beam of light in a dark room? You will see it to be straight. This is called rectilinear propagation of light. You will only be able to see the flame when all the 3 holes are in one straight line. This shows that light travels in a straight line. Reflection of light from plane mirror. We learnt in class 6 that different materials behave differently towards light. Transparent materials allow the light to pass through them. Translucent materials allow the light to pass partially, and opaque materials reflect the light completely. We are able to see an object when the light falling on it comes back and enters our eyes. The best example of reflection is your image when you stand in front of the mirror. When light from a luminous body falls on you, your body reflects the light. This reflected light falls on the mirror and gets reflected back into your eyes, helping you see yourself in the mirror. Would you be able to see yourself in the mirror in dark? Why? Angle I is called the angle of incidence and angle R is called the angle of reflection. The law of reflection states that the angle at which a beam of light falls on a mirror, angle I, is equal to the angle at which this beam gets reflected, angle R. Thus, angle I is equal to angle R. Reflection can take place from any smooth surface. You will be able to see your image completely or partially in a glass, in a stainless steel plate, in a pond, or even in a bucket of water. Let us learn some properties of the image formed by reflection. Based on the above activity, we can discuss the properties of the image formed by a plane mirror. 1. The image is formed at the same distance behind the mirror. 2. The image formed is virtual. This means the image cannot be transferred to a screen. If you look behind the mirror, there will be no image. 3. The image formed has the same size as the object. 4. The image is erect. 5. The image shows lateral inversion. This means if you tilt the object towards the right side, in the mirror it will tilt towards left side. Reflection of light from curved mirror. Take a new stainless steel spoon from your mother and look into it. Do you see your face? Look for your face on both sides of the spoon. You will be able to see your face clearly on the back side, but it will look inverted. Curved or spherical mirrors are similar to the spoon. In a spherical mirror, the reflecting surface is curved. The mirror can be thought of as a part of a sphere. Spherical mirrors are of two types. 1. Concave mirror. If the reflecting surface of the mirror is the inside of the curve, it is called concave mirror. 2. Convex mirror. If the reflecting surface is the outside of the curve, it is called a convex mirror. Let us learn more about both types of mirrors. Concave mirror. A concave mirror is called a converging mirror. If a set of parallel rays fall on a concave mirror, they reflect and meet at one point. Hence, it is called a converging mirror, and the point at which the rays meet is called the focus of the mirror. The distance from the focus to the mirror is called its focal length. Let us learn about the image formed by a concave mirror. Let us explain the observations in the activity. The nature of image formed depends upon the distance of object and mirror. When the object is between the focus and the mirror, the image formed is virtual, erect and magnified. As the object moves beyond focus, the image is real, magnified and inverted. Convex mirror. A convex mirror is called a diverging mirror. This is because the parallel rays of light falling on the mirror appear to converge at one point behind the mirror. This point is called the focus, F. As the rays appear to meet at F behind the mirror, the image formed is always virtual. Uses of spherical mirrors. Concave mirrors. Since concave mirrors are converging, they are used to collect light, energy, sound and TV signals. Concave mirrors are used to converge sunlight at a point which becomes very hot. This property makes it useful for solar heaters and cookers. Huge concave mirrors are used in telescopes to form images of distant stars and planets. Concave mirrors are used in headlights of cars and in torches. The light reflects from the mirror and converges to form a bright beam. When an object is very close to a concave mirror, it forms an enlarged and erect image of the object. This property makes it useful for dentists to see enlarged images of the teeth in the mouth of patients. People to use concave mirrors for doing makeup and shaving. Convex mirror. Convex mirror forms an erect and diminished image of an object. They are useful to obtain a wide view of an area. They are used as rearview mirrors of cars, as they give a smaller and wider view. Security mirrors in an area to cover a larger view. Lenses. Do you know how you are able to read these lines? It is with the help of a transparent lens in your eyes which helps to form images on your retina. You may have seen lenses often without realizing it. The spectacles, contact lenses and magnifying glass, etc. contain lenses. Let us learn what are lenses and how they work. A lens is a transparent, curved surface made up of high-quality glass or transparent plastic. Like curved mirrors, lenses are also of two types. 1. Convex lens. It is thicker in the middle and thinner on the edges. 2. Concave lens. It is thinner in the middle and thicker at the edges. You can imagine the two sides of a lens to be parts of two spheres. The center point of a lens is called its optical center. The line joining the centers of two spheres, of which the two sides of lens are apart, is called its principal axis. Let us see how images are formed by these lenses. Convex lens. Convex lens is called the converging lens. The parallel rays of light falling on a convex lens converge at one point on the other side of the lens. This point is called the principal focus, F, of the lens. From this activity we can conclude that the convex lens forms a virtual and magnified image on the same side as the object, when the object is placed very close to it. A real, converted and magnified image on the other side when the object is moved away. The size of the image decreases with the distance. Concave lens. A concave lens is a diverging lens. Rays of light falling on a concave lens are bent away from its principal axis. If you look through the lens, these rays will appear to converge at one point. This is called the principal focus of the lens. As a result of this, the image is formed on the same side as the object, and it is virtual, erect, and diminished. How do these lenses work? We have learnt that light travels in a straight line. However, when light enters from one medium to another, its direction changes. This is called bending of light. When light enters the lens from air, its direction changes. In case of a convex lens, it bends towards the principal axis. Hence the lens is called converging lens. In concave lens, it bends away from the principal axis, hence it is called a diverging lens. Splitting of light. Not only glass, light can be bent by any medium. Sometimes the water droplets in the air also bend light passing through it. While the light passes through the water drops, it splits into different colors. White light is made up of 7 colors, so you see it as a band of 7 colors across the sky. This is what you know as a rainbow. You can also observe the splitting of light on a white CD or in droplets of oil or in soap bubbles. From the above discussion and activity, we learn that light is made up of different colors. So, if we mix these colors, we should get white light. This happens because, when the disk rotates very fast, our eyes are not able to detect different colors, and we see the disk as white. In a nutshell, light shows rectilinear propagation, that is, it travels in a straight line. Light falling on a plane mirror gets reflected. A plane mirror forms a virtual image, the same size as that of an object. A curved mirror with the outer surface reflecting is called a convex mirror. A convex mirror always forms a virtual, erect and diminished image of an object. A curved mirror with inner surface reflecting is called a concave mirror. A concave mirror forms a virtual and magnified image when the object is too close to it. When the object is slightly far, it forms a real, an inverted image. A lens is a device made of a transparent substance with curved surfaces. A convex lens is thicker at the center and thinner at the edges. A convex lens forms a real or virtual image of an object, depending on its distance from the lens. A concave lens is thinner in the middle and thicker at the edges. A concave mirror always forms a visual, erect and diminished image of the object. When white light is passed through a prism, it breaks down into its constituent colors.